So sorry about the messed up slides. I uploaded new ones and they aren't there. Is there any other, is there a working group chair here who remembers how to make Mitico believe in the new slides? I have uploaded new slides, so it somehow is remembering old slides and not new ones. I'm not going to worry about it if not.
I haven't seen that.
Okay.
yet.
Yeah, no, okay, yeah, didn't do that. Okay. Okay. So pretend that you can see both of them. I think we're gonna start. Can someone close the back door? Can someone sneeze? Both of them have happened. That's great. So, greetings. This is the PQUIP working group. I'm Paul Hoffman. Sophia is not online, I don't think, or she's not being acknowledged. She is not. If you're new to the working group, we've got plenty of presentations today. We'll go through the agenda in a moment. If you're familiar with the working group, the agenda is almost identical to the way it was in Brisbane. We've got updates, but we're still sort of in the same state we were before. So welcome. Turning off the phone. Any of you who live in California, you might be getting beeps if you're using Firewatch. Are you coming up to get ready to speak? We've still got a few more minutes to go through, so that's fine. Okay, now the note well is already too small, and now it's half size, so I really apologize for that. Having said that, you all agreed to the note well when you registered. If there's anyone in the room who's not registered, you should be. But the note well is sort of a historical thing in the IETF of things you're supposed to know. It's not just supposed to know. You really, really, really are supposed to know this. Especially in a working group where there might be intellectual property, things like that. If you breezed over the note well when you registered, I highly propose that you go and read it like this evening at dinner or whatever. There is actually interesting stuff in it. It has evolved over time. So now there is the new note, or the note really well, which is it's sort of for the old timers here. Remember, the Dow of the IETF was 30 pages, then it was 60 pages, and then it was a website, stuff like that. We're that way with the note wells, but this one is not about like legal responsibilities. This is about expectations. We are expected to treat each other well. We're expected to disagree with each other cordially. We are expected to come from places of truth, not places of opinion, if we can. Of course, we all have opinions, but a really good practice when you hear somebody who is probably in the same intelligence quartile as you are, disagreeing with something you think, is to shut up and think about it. Okay? This is a working group meeting face to face. We also have a mailing list. Our mailing list is not that active, but it could be, especially when there are disagreements suggested for new things and such like that. So this page, which you didn't agree to, and unfortunately you can't really read, says, really, let's act like adults, but let's act like good adults, okay? And then the meeting tips, basically, if you're in here, we want to know that you're here. And the way to do that is to sign in with either the QR code over there, or if you have the agenda open, to click on the icon that says, I forget the exact float over wording. It says on-site tool. Okay. We aren't doing blue sheets anymore. This room is not super full, but this is sort of the right amount. But if in working groups where not enough people do that, they end up relegated to smaller rooms. So, and then there are other meeting tips. You will see these slides, But again, what's most important here is that the best way for us to work together is to work together. Okay, so we've got an agenda, and like I say, it's pretty much the same agenda that we had before. We're going to cover the post-quantum cryptography for engineers. We're going to cover the terminology for hybrids. We're then going to move into the hybrid signature spectrums document, which is now a working group document. We've got a longish presentation from NIST, which is what I think a lot of people really want to hear. Quinn, I hope you're up for that. Okay, that's fine. There will be questions. And then we have a couple of newish documents on the migration use cases and hash-based signatures. So sort of what we did before, but with newer documents. Normally, this is where a chair would say, does anyone want to add any other business stuff? I'm not going to ask that now. If we finish early and you have other business, great. Generally, things that might pop up here, like at a last minute, are most appropriate, in fact, for SAG. And that's on Thursday for the security area group, because often this working group is sort of cross IETF security, so is SAG. So if we have time and you have something great, we'll see at the end. With that, I'm going to get out of these slides and go into post-quantum cryptography for engineers, share slides. And this is a good size. That's actually supposed to be forwards, and you're supposed to stand.
I'm supposed to be standing
on the pink X.
So directly beneath the piano, I think.
Oh, and
all right. This is not going to take 10 minutes unless there are lots of questions, because we've been working on this for a while and it's in reasonably good shape. So unfortunately, the first author couldn't be here, so I'm presenting for the team. So next slide, please. So for those of you who haven't seen this before, if it's your first meeting, we do have a draft here, PQC for engineers. And what it explains is it basically explains why engineers need to be aware of and understand post-quantum cryptography, and then gets into a lot of the details that engineers care about and leaves out a lot of the details engineers don't care about. So it's a very IETF focused PQC primer intended to help people get up to speed on this very important topic as it becomes more and more relevant. And so if you've been following this, people love the term cryptographically relevant quantum computer, in part because it looks like a different word. But the Crocs are what are actually going to cause the problem. They're quantum computers that are actually large enough to break RSA and ECC. That's very different from the ones that exist today. These aren't things that exist today, but they will soon in a couple of years. And so we're going to need to... Sorry. Where insert whatever number you like for a couple. And so, there's a lot of debate over exactly when, but it's more of a question of when, not if at this point. And so PQC for engineers was adopted by the working group following IETF 117, and there's been a lot of work on it since then. Next slide. And since Brisbane, I unfortunately wasn't able to be here in Brisbane due to a chair conflict, but the work since then is basically resolving all of the outstanding issues, which was basically changing all of the algorithm names to the NIST names like MLChem and so on. There were a couple of other typo fixes and things like that, but that's about it. There really haven't been any major changes since IETF 119, nor has anybody really asked for any. So next slide. We think we might be done. And so we're suggesting that a good way of finding any remaining work that needs to be done might be actually to have a working group last call after IETF 120. And then we'll go through and see what we can get fixed out. And then hopefully it will actually be an RFC, hopefully shortly after, depending on the timelines, shortly after the NIST algorithms themselves come out. So it would be very useful timing if we get this out. If there are other things we want to address later, we can always BIS it. I think that's kind of inevitable at this point, that over the next couple of years, there'll be stuff that comes up. But I don't think it's worthwhile massaging this until it's perfect. I think the timing's kind of good now. So let's everybody take a read on it. If everybody agrees, let's all take a read. Let's all figure out what the last few nits are, and let's get this one done.
So before you go,
Yep.
who in the room has read this document once and is not like a heavy cryptographer? So you put your hand down, Deirdre. Okay, so the people with your hand up, if you can read it again or skim it again and note what you would have also liked to see. So what Tim's been asking for is nits, and I think we are at the nit stage. But if you all read it again and go, oh yeah, I really get this, but I didn't see a section on this, or I've been hearing about this, and send that to the mailing list either now or during the working group last call. Again, this working group's a little bit odd. We're not doing protocols. We're explicitly prevented from doing protocols. But this document's going to help a heck of a lot of other people, especially outside the IETF. So having it be correct is one thing, but having it be full is also a really good one. So if you can do that now or during the working group last call, that would be great. Any other, I'm not seeing anyone in the mic line who wants to comment. Any other comments on this? Sophia and I will talk, and I think I think you're right. There has been so little on this that a working group last call might flush out other things. So great. Thank you, Tim.
Thank you.
Okay. Next up is Michael for another terminology document, but this is on hybrid schemes. So let me see if I can. Hybrid signatures, no, wait, got that wrong again. Hybrid terminology, there you go. That's you. That's you.
Hi, everyone. If you're familiar with this draft previously, you've been presented by Flo. So a brief introduction. I'm Michael, I'm Flo's colleague and a co-author on this draft. So as Paul said, just going to give a few updates on where we've got to with it. So for those less familiar, a little bit of background. This draft aims to standardize terminology for post-quantum traditional hybrids. The main idea is to make sure that when conversations are happening, there's no misunderstandings. People aren't using the same word for different things or meaning different things and getting confused. I think it's in quite a good place. It's used a lot across IETF and actually even wider in places like GSMA. So we think we're doing quite well, but really interested in your thoughts as well. It was adopted following IETF in Japan. We did a working group last call in about February of this year, and as is often the way with working group last call, we got loads of feedback and suggestions. So thank you for those. And on the next slide, I've got some of those. I should say this isn't an exhaustive list, but here's just a few examples of some of the updates. Please do have a look at the diff. If you're interested, I'll be around afterwards as well. So firstly, we wanted to make sure it was clear what we were talking about with PQT hybrids. So in particular, an example of one of the things that came up that wasn't quite in scope was things like using a chem and a pre-shared key for your solution. That's not quite what this draft is talking about, so we wanted to be a bit more explicit about that. Similarly, there was some ambiguity about the word composite, sometimes being used interchangeably with hybrids, sometimes people misunderstanding exactly what that meant. So we added some text there to make that a bit clearer. And thanks to all who helped out making sure that we've got that consistent with other use cases. Similarly, there was I think there was a comment on the mailing list about making sure we weren't overselling the security properties when using the term PQC. We made the decision not to change and not use PQC. It's so widely used. We wanted to have it in there, but adding a bit of a caveat to make sure people understood exactly what we meant and exactly what they were getting. And finally, we removed some of the definitions on separability. They were more suitable for the signature spectrums draft, which I think we're hearing about next. So we had a bit of redundancy there, and it wasn't needed. You know, this draft is very much kind of the base definitions that everyone's using. So the more specific ones fit better in that draft. I guess as part of working group last call, we had a few more conversations which maybe fit in this draft and maybe don't. I'm interested in people's thoughts. So in Brisbane, we had a suggestion, I think it was for private key abuse, but more widely about anti-patterns or considerations that you need to take into account when using hybrids. It's not currently in the draft. We could add it to the draft, but I posted the mailing list, and I think if there is another draft, maybe existing or maybe not, that looks into the security analysis more deeply, that might be a better place for those sorts of terms. But interested in people's opinions. Similarly, it sparked very interesting conversations about complexity and about some of the operational considerations that people were experiencing when thinking about hybrids. Again, that's not quite appropriate for this draft. It's just about the terminology. It's not trying to take a position that people might have different perspectives on. It's just trying to provide that kind of baseline to enable those conversations. So this is my last slide. I guess next is to decide what to do next. As I said, the definitions are used pretty widely across IETF. And I think that shows two things. Firstly, that we've probably got that base set of definitions about right if they're being used consistently and people agreeing with them and finding them useful. So that's really good news. The other point is, as an author, I'm really hesitant to change those base definitions. I don't want to undermine other people's work. So the only other consideration is if there are other definitions to add, please do let me know. I guess personal perspective is some of the suggestions recently, I guess like the separability ones or like the anti-patterns ones might work better in other drafts and treat this one as just the baseline ones, but keen on people's thoughts.
I'm not seeing anyone in the mic line. I suspect we will do another working group last call because there were a fair number of changes.
Yep.
Anyone here who is in one of the other working groups that is using this draft? Anyone with comments that you're, I haven't seen, are there ones, are there people who are normatively pointing to this draft?
I think not necessarily normatively.
Okay, John?
Yeah, I was just going to say, yeah, it's John Gray from Entrust.
Yep.
Yeah, I was just going to say this is a good document. Like you said, it's like the baseline. We know cryptography continues to change. There's going to be new algorithms. There's going to be probably new mechanisms that come up in the future. Having definitions for those are going to be needed. I don't think we should wait, this document. I think we are using this terminology. I think having it set in stone, right, and then we can have future documents. I think that makes a lot of sense.
Okay, thanks. And during the working group last call, we will also ask about the scope one, where do we want to put these bigger ideas in, or in fact, is someone interested in doing what really would be a document about how to put these together, not the words of putting them together. I'm sorry, with anti-patterns, how not to put them together, but operational considerations and such like that. But we'll do that during working group last call as well. So
Thank you.
I don't see any more in the line. Thanks. Okay, Deirdre? And you are this one.
The
Yes, you
other
are.
hybrid.
There you go.
Cool.
Cool.
As mentioned, this is hybrid signature spectrums with myself, Britta, Nina, and Flo.
Oops, why is this not?
There we go.
Yep.
Sometime before this meeting on the list, this was adopted. This is a description of different security properties and spectrums of those properties in relation to how one can construct hybrid signatures using a post-quantum and traditional as component algorithms. Next. Some of the properties that we care about in terms of signatures that are not really present in chems are these notions of separability or non-separability. So this is one of the high-level properties that we go through in this document, from all the way to no non-separability. There's no evidence or artifact that there was supposed to be a hybrid signature composed of two component algorithms that you're supposed to verify together. No artifacts exist that that was the case, to all the way down to strong non-separability with simultaneous verification, so that it's very clear that this is a hybrid signature and it cannot be verified in pieces. Any of the component algorithms cannot be verified independently of the other. It's all one go. So there's like one spectrum of separability. There's also notions of generality and sort of when you have pre-approved software modules, say as like a FIPS module, how can you combine them, and kind of another spectrum to create these hybrid signatures. Sometimes you might have a construction that you can't reuse any of these things as a black box. You have to go down into the guts, split it apart, put them back together again, and you get a lovely hybrid signature, but you can't reuse anything that you've already gotten approved before, or you have to dive into, an API boundary that you really would not like to, all the way down to ways that you can combine them. That's like, you don't have to know about the innards at all. You can just like kind of plug them together. That's another one. And then artifact locations, where in this signature or the use of the signature or in the key material or all of the above, do you have indications or evidence of the hybridness and what kinds of component algorithms you have in this hybrid signature? Next. So when we did our adoption call, we got some asks for more language in the document on why one would use a hybrid signature, a hybrid PQ traditional signature, versus not going PQ at all, or going directly to PQ and not doing hybrid at all. And then also more language about whether or not you want to do hybrid signatures at all, because for some people you don't care and some people you really, really do care. But we're not prescribing about whether you should adopt, just language about you may or may not want to. We're not assuming that hybrid signatures are strictly necessary in a general case. We're just describing a lot of these kind of spectrums of notions that apply to hybrid signature constructions.
So, and this is the part where we think there's going to be most interest in the working group of, like, do the things that you're doing in your other working groups, is it matching this? Have we tilted too far and such like that? So consensus on this might be hard, but this is a super important part.
Yeah. So please reread the updated, adopted draft. If there isn't a lot of, dispute or dissent, we don't know if there's anything else that the working group wants from it. If you like it, maybe we try a last call, and that would actually suss out anything that anyone actually cares about. Yep.
And I forget, you have other slides.
Yeah, that's just links.
Right.
Right. So we have not included any concrete constructions of these things. We've kind of hand waved and included links to other work as references of ways one can approach it. People have expressed interest, at least seeing what a strong non-separable fused hybrid, which is one of the ways you can construct one that we lay out in the document, like an example of that. Like if they wanted to try it out, if they wanted to build it, if they want to try it to, include it somewhere. We don't think that that belongs in this document, of course, but if we want to see something like that go forward, there's kind of similar work going forward in CFRG on hybrid chems. They've just concluded a hybrid chem design team to get specs out for a about to start, I think, hybrid chem document that will lay out very specific concrete chem, like very specific parameter sets and designs. If there is interest in concrete hybrid signature designs, I think something like that process would be probably best, or that probably would work out pretty well. But I don't think we're there yet. I think everyone is paying more attention to store now, decrypt later attacks. And so they're migrating to hybrid chems or post-quantum chems now, and they're waiting a little bit to deal with post-quantum secure signatures. And so I think we have some time. But if people are interested in concrete hybrid signatures, I think that may be the way it will move forward in IETF, not necessarily kind of piggybacking off of this document in this working group.
So would you say that if that work was being done, that should be done in CFRG or here?
I think
Have they done enough legwork for hybrid chems for us to do it here, or should this still be a CFRG work
I would
item?
lean towards CFRG.
Okay, fine. Yeah,
Yeah.
I thought they were quite different, but yeah, I just wanted.
So I'm just sort of kind of underlying that like we aren't expecting to like start sketching up
Okay,
concrete hybrid designs and parameter sets
right.
coming out of this document in this group.
Mhm.
I think it would look more like what's happening in CFRG and happen in CFRG
Okay.
if people are interested
And
eventually.
is your last slide a?
Yeah,
Oh.
that's just what I said.
Okay, great. Let's go back on this one.
Sure.
And the Q line is Britta.
She told me to skip her.
Okay, that's fine.
Yeah, just a question. I want to, and I'm sorry if I'm just behind the ball on this. I want to understand what the use cases are for fuse hybrids, like why people want to do this.
Okay, fused is like kind of the strongest non-separable kind of construction that we do lay out. And it's basically, if you don't care so much about like, I've got RSA over here, or I've got, let's just say ECDSA over here, and I've got MLDSA over here, and I want to like swap them or have options of doing one and smushing them together with another one because I don't want to generate two signatures. If you don't care about that and you just want to be like, this is my, reactor named MLDSA, ECDSA, fuse signature. It will be one signature API type. It'll have a key that is only one type. You can't split it up. You'll have a signature. You can't verify one part and split off the other and just pretend. You'll have strong verification. That's a little bit stronger, but you can get that. Strong non-separability really gives you just sort of like the way that X-Wing is just all in one. These fused strong non-separable constructions are very much like that. It is like all bundled up one signature, one hybrid signature. That may be a little bit annoying if you're a builder, but it's very nice and wrapped up in one little box if you're just a cryptographer and you don't care about code duplication, you don't care about this other stuff. You just have one OIN for it.
So I guess what's the difference? Like, is there an attack that's prevented by a strong non-separable signature scheme, like versus like whatever the next tier down is? What is like the attack that this stronger thing stops?
And by the way,
Great question.
when you come to the mic, please say who you are so remote people can.
Yes, so Britta Hale.
Yep.
So that is a great question. So what you get out of strong non-separability is essentially your classic signature performance, which is a little bit different than if you have any other version of hybrid. So assuming you were doing a hybrid, any other version, if you do parallel, concatenated, etc., you can put it in policy, you can put it where it's auditable in retrospect of whether or not you could have had an attack where someone did basically signature stripping. What you get out of fuse hybrids is basically a simple signature approach. It either verifies or it fails. If it fails, then you have an attack on one of the two composite components. So this is really the most one-to-one matching to a traditional signature that you can get out of a true hybrid. The one other aspect of use case that's a consideration for fuse hybrids is that there is a sort of forward compatibility benefit from it, that this is a single algorithm. And if you do want to do a hybrid, then you don't need to change your policy, your protocol, or anything else. It is a single cipher suite. And if at any point in time you need to roll that to a post-quantum only or whichever else, it is a simple replacement.
Yep.
So it's actually probably a very clean version. Now, there's probably overhead costs depending on what sort of system you implement it on. So there's trade-offs. And that's why it's being raised here among this group. I agree, and notice the chat. This is not the CFRG, and we're not proposing it here. This is a question for this group of engineers and users to say, is there interest in this as a possible use that we would push this in forward into the CFRG, et cetera. So it was proposed here before. It was asked about whether there could be a draft, just seeing what other possible interest is there might be to see such a draft, and then it would go the appropriate route through a more cryptographic review.
Great, thank you. Michael?
Interesting work. I definitely understand the motivation for it. It feels a little more CFRG, specific than here, just for a variety of reasons. Whenever we start merging things together that might have unknown properties, I know in theory this should all be fine, right? But just there's aspects of this that make me just give me some pause and nervousness, right? Especially because we're saying, yep, we're going to go hide this complexity and it should be fine. You can just treat it the same way as everything else. I've seen those promises before, and then I've seen them get deployed in different systems and things like that, and then cause problems. So that's why just have some pause.
Great. Scott, you had put yourself in the queue, you took out, okay, fine. So, do you think we should be asking the question of, is there interest in discussing this draft, or is that a separable question?
Separate. I think it's a separate question,
Okay,
because
fine.
we're seeking input so that if we have enough input, we could go to CFRG and be like, here's our draft of a fused, strong, non-separable construction. It uses, P56 and it uses MLDSA, and
Right.
do you like this? But we'll go to CFRG with it.
Got it.
And then here, working group last call may shake out anything for this document.
Right. Okay. And you're feeling at this point, I'm speaking to both of you, even though one of you is quite far away and one of you is even further away, that you are at top of stack for the known questions on the draft.
I think we are, yeah.
Britta, do you agree?
Yeah, all the questions that have been raised on the mailing list, we've addressed all those. We
Great.
haven't seen anything else come in. So the spectrum draft, which is more of a comparison terminology, which we're kind of hit baseline on that before getting into this question, is it a working group last call? I think it's good to push it there. If people have further things, that tends to flesh them out at that point. But we haven't seen anything and haven't heard anything more.
Great.
So that, I would say,
I'm
this is
seeing
more of
working
a
group
separate
last
question
calls
of
getting
hearing.
lined up here, but
Yeah.
yes. Okay, very good. Thank you. Anything else, John?
Yeah, I was just going to say, I'd be interested in a strong non-separable where you have two black boxes. I was talking to Britta a bit about this just before this meeting. I think it could be possible, but it would require a change to the signature API itself, because it would have to return a piece of data that then would obviously go into the secondary signature. So I think that would be interesting to look at, because I think with two black boxes, right, like if you have something like FIPS or whatever, one of them could be and maybe not. So I think there could be advantages for that. So I think that would be definitely worth looking at, and
Cool.
I'd be happy to have discussions about that.
Awesome.
Great, thanks. And those, even those are discussions that'll end up for the CFRGs. Those can happen here if we see use cases across the IETF for something like that. Like, where what she said was known and known, and you're saying unknown and unknown. If there are use cases to come up, this is a perfectly appropriate list for it. But great.
Cool.
Great.
Thank you.
Thank you. Okay. And right. NIST. Is that you? Quinn, are you doing it? I know, let me get you up here. Sharing. Okay.
Hello, I'm Quinn Dang at NIST, and it turned out to be today is perfect time for giving this talk. Last week, we were told that today we're going to be the last day to make any edits to the FIPS. So this is a perfect timing to give this status updates to all of you over here.
Great.
So let me go over a brief introduction of NIST. We are actually non-regulatory federal agency within the Department of Commerce. And before 1988, our name was different. It was called the National Bureau of Standards. And then after that time, Congress gave us a new name, and which is NIST today. And we are in Gettysburg, Maryland. And we have another campus in Boulder, Colorado. And we are about 6,000 people, including all the guest researchers and associates and all the supporting staff and everybody else. And one more thing I'm very proud of. We have won at least 5 Nobel Prizes. Awesome. Loveness. Next slide.
I get a bit jaded because I live on a street named after a Nobel Prize winner in a whole neighborhood where there are all Nobel Prize winners on the name. So,
And we have a long history of crypto work. And the big one with this was in the 1970. We standardized DEST, and that was the first symmetric key crypto that we produced. And unfortunately, DEST is dead right now. But after that, the demand for better crypto, better security options have been growing very much over the last few decades, maybe 4 or 5 decades now. So we have produced more crypto standards and guidelines, and we continue doing today. And in today, we are very happy to see that nearly a lot of big computing devices like laptops we have today, they all have a crypto and quite often have FIPS validated or using NIST crypto algorithms or functions in them. Next slide. And right now we're here today to talk about post-quantum cryptography and how to deal with the quantum computers in the future, and what that would do to what we are having today with the cyberspace and all the e-commerce and all the advanced technology that we're having today, enjoying today. They very much got it from cryptography. Without cryptography, we wouldn't get the advanced and really good society that we have been enjoying today. For the public key cryptography, we mainly have 3 areas or 3 documents that are 56A and 56B, where we standardize, specify how to do different Herman types based on different groups and techniques. And also we have signatures based on that is in FIPS 186. They include RSA, DSA, AddDSA, and ECDSA. And these will be all broken when we have a good enough quantum computer. So that's what we need to deal with. And on the symmetric key side, our standards will be affected, but not like broken. It's still square root the security strength key size. So we strongly believe it will be still okay. They are AES, a SHA-2, SHA-3 kind of family. Next slide, please. Yeah, so our job has been to do research and to look into new algorithms which will be secure in classical world and post-quantum world as well. So basically, they would be secure against classical attack and quantum attacks or both. So that's what we have named quantum resistant cryptography or post-quantum cryptography. Those 2 names have been widely used, and they basically mean the same to us in this definition. Next slide.
if someone has their speaker on, you can silence that. Thanks.
Next. Yeah. The post-quantum cryptography research in that area has been going on for like a few decades now. And there are 5 main areas that we have seen and we have received submissions from. We have ladders, we have code-based, we have multivariates, we have symmetric hash-based algorithms, and we also have elliptic curve exogenous based. And yeah, so we have a variety of foundational post-quantum cryptography to go from. Next slide, please. And more concretely, in 2016, we before that we did research and we had workshop to discuss about post-quantum cryptography. But officially in 2016, we make a call for submitting algorithms. Everybody in the world could submit candidates to us for review and to analyze and to share with the whole world about their design as well. And our role, our role was and has been to be review the submissions carefully, looking at all the analysis or reviews that we know in the literature or anywhere, and then get all the data about performance and the additional properties that the candidates or the algorithms have. And based on that, we would make decision moving forward and how to go from there. And it's more like we relax, or not relax, but we change the direction how to handle the post-quantum processes different from how we did with SHA-3 and AES. We allowed ourselves to have reserve a little flexibility to improve, potentially improve the candidates or the algorithms at the end, to make some changes based on what we have learned and based on the feedback that we receive, instead of like sticking to the submission from the authors. And we also knew that we did not envision there was going to be only one chosen one, and there were going to be several, and it turned out to be the case as well. Next slide, please. And in order to help the designers what to design, what the target they're looking at, and then we're looking at the practical security levels that we knew and widely accepted it or widely understood at the time. And we those are 5 levels that we have over here. So the easiest one at level 1 is the AES key search on single key search on AES 128. And the higher level is the collision on SHA-256. And the next level is you do a single key search on AES 192. And the next level is you do the collision on SHA-384. And the level 5 is AES 256. I'm sorry, the third one is 192. The fifth one is 256. Again, single key search. We're not talking about multiple key attack or security level, because that would depend on how many keys you're talking about. So we cannot, we did not want to define something like that for the designer to target at. And also we measure, of course, in performance and different platforms, different dimensions like the ciphertext, how large is ciphertext, how large are the keys, and how large are the signatures, and how do the algorithms perform on different machines, etc. And in protocols, of course. We cared about how the algorithms would be good or not good in current protocols. That's something we really care about. And we also care about the other properties that an algorithm or candidate has or does not have. Certainly, like we care if you do drop-in replacement of in the current protocols, what would be the cost, and what would be the pros and cons for each candidate. And then we really are promoting forward secrecy. So basically, we prefer CAM to be in ephemeral key use case rather than the static key use generally. And also, we prefer candidates to be resistant to or easier or cheaper to be implemented in a way so that it resistant to certain side channel attacks. But we are aware that side channel attacks keep coming with new ways and more advanced. So, but you know, we want the best that we could have at the moment. Also, we prefer simplicity and flexibility. Simplicity basically helps the reviewers and the people to have more confidence in the design. If something too complex, and it would take more time for people to feel confident about it. But something simple like ACC, for example, that's quite easy to understand how it works and why it's secure. For the flexibility, basically means if with this parameter I don't have enough security. If I want better security, how costly that would be. So the flexibility basically means when you go to upper level or lower level, the changes are minimal, and that would preserve a lot or most of the crypto analysis have been done on the candidates. So that's what simplicity basically means. And of course, again, we like multi-resistant candidates rather than non-reuse one time and then you're gone. Next slide, please. And here's a brief history of the last several years that we have gone for. The round one, we ended in 18. At that time, round one, we have 69 candidates. And we are very happy that we have close to 300 submitters. That's really awesome. And the candidates are coming from 6 continents. And we at each round we held one workshop to discuss about the candidates, discuss about the reviews and the analysis that we received. And at the end, we have a report for that. For the round 2, we have 26 candidates, and we have 7. I'm sorry. At the time, was 7 broken, and then we have the same thing. We held a workshop, and then we generate a report at the end after the second round. On the third round, we have 7 finalists, and we have 8 alternative candidates. And at the end, we decided to choose 4 at the standardization choices, which are we all know the Lithium, Kyber, and Spring Plus, and Falcon. Next slide, please. So here are the finalists, the one we are working on, and 3 of them are about to be done. And Falcon is in a good shape and expected to be available for review sometime this year. And we also having 2 other processes are going on very actively, which are very important. The 4-round CAM, we are working on the Classified Elite, Spike, and HQC. Psych is gone, had been acknowledged to be broken, and Psych won't move forward. And for the on-ramp signatures, we prefer to find something which is not lattice based, But if it's less space, then it must have additional properties, advantages over the Falcon and the Lithium. And we prefer something which has short signatures and hopefully fast verification. Because the Lithium right now, in some cases, people may say it's a little, it's not small enough for me to like it much. So that's why we're really looking for something which has short signature. Next slide, please. Yeah, and here are the four standardizations ones that we're having. We have MLChem, that is Kyber. We have MLDSA, that is the Lithium, and Falcon and Spin Plus. For MLChem, it's good all around in terms of security and performance, and it gives us 3 options for security level 1, 3, 5, which is exactly what we really want. We didn't want 5 level, 5 different parameter sets, and 3 seem to be right to us. MLDSA, we have 3 level as well, 2, 3, and 5. And overall, it's good performance and it security strengths. Again, it just might not be small enough in some cases. It's signature. And so Falcon, we have better size and signature size. But Falcon is a little more tricky and could in how to make it side channel resistant, basically for a constant time implementation, to be resistant to side channel attack on the signing process. But it has the advantage over the Lithium. It's smaller. That's the main advantage. And for Spin Plus, we really like Spin Plus. It's solid in security. It's good to go. But sometimes if you feel like it's big enough for you to handle, then then we're working on a better solution for that. Next slide, please. So here is roughly the performance interrupt cycles regarding to signing and verification. You can see that the MLDSA level 2 is quite good. Like it's really even better or compatible overall, even better if you use a total signing plus verification times for each candidate. Then MLDSA even better than ECDSA. And Falcon is very good, and all of them much better than RSA. Yeah, next slide, please. And here is their sizes with the 4 of them, and no, not the 5 of them compared with RSA and ECDSA. Yeah, the post-quantum candidates right now, we have the signatures the signatures are larger than the classical one. Even the keys are larger as well. I'm sorry. Yeah, but that is the best we have right now. Yeah, next slide. For MLChem, we have three options. For level 1, the NCAP key is not bad, not bytes, and the cipher attack is even less than 800 bytes. So that's quite good in I think in current protocols. The next level 3, is a little bit bigger, and with the additional information in the data package. I'm not sure if it would make the fragmentation in key exchange or not. I'm not too sure about that. And we have the level 5 is a bigger as well. Next slide, please. Oh, and one more. Yeah, this here. And one important thing. So thank you for several people like. From I'm sorry, I can't remember them right now. They gave us a suggestion to allow allowed to saving the seed instead of saving the private key, because the seed are a lot smaller. The private key in MLChem is large. So that means when you do decap, you can regenerate the key pair and you do the decap. So you pay a little cycles for the keychain. But if you don't do the decap frequently and you care about the storage, then storing a seed seems to be a lot easier or cheaper than storing a large decap key. And we allow that in the FIPS.
So that's a definite?
Yeah,
Okay,
it's,
fine. Okay.
we have that in the FIPS.
Okay, good.
So here the summary of the history we have been so far since 2016. We already passed the red dot, but we have not at the end yet. The end is coming soon. The end is coming soon. It's coming soon. Coming soon. I strongly believe it will. I strongly believe that there's a good chance it will be done soon.
Great. I love. For those of you who don't know, I give him grief about this every time.
Because
so.
you give me a coach. I kind of because that has a lot of implications.
Yeah. No, I give him grief about it.
But I strongly believe because we're pushing really hard and the FIPS technically ready and we started the legal process.
Great.
And we're pushing up and yeah.
And you said comments had to be in by today, so no more changes.
I was told that today was the last day any edits could be made to the FIPS.
Right.
That means I could, but it would be I would be fired or something. I don't know.
No. Don't do that.
So here they are. So the 4 FIPS are coming, and the Falcon is under development very actively. We have a lot of content done, but Falcon needs a little more time. And also we want people to focus on the MLDSA, because that's our primary recommendation, and it's a little lost and mostly and some people wishes, but if it works for you, fine, then go with it. So we finished. We revised the draft FIPS based on what we received during the call for comments, and also a lot of other comments and discussion over the forum over last year. So thank you for all of those. I think this has been really wonderful. And you can go to our website to get more information, or you can talk to me or email me with any specific things that you would like more on. And if you like, go to the PQC forum. It's available, and you can read all the discussions regarding to different technical aspects of a lot of things. And if some technical detail or information that you would like to know, contact us or contact me, and I will do the best I can to point you to the right place to get more understanding. Next slide, please. Yeah, so the process of the FIP is that we submit the proposed FIPS up the chain in the legal matter, and at the top, the Secretary of Commerce would have to sign it so that it would become official. And along with the FIPS, there would be a federal register notice, which includes a lot of some main comments that we received, and we provided our responses to those comments in the notice. But we couldn't put everything on the notice. But with any comments or questions that you want, you just let us know. Yeah, for the 4th round, that's the 3 candidates we have in right now. Site is ours. Classified Elite, we are very confident with in its security. The only things we really want more feedback is that how many people, how many corporations are going to actually deploy it, because we want to standardize it, but we don't want to standardize something that nobody wants to use. And between Bike and HQC, Bike has better performance, But HQC we have more understanding of its security in CCA security. We might have more confidence in its security, in its security proof, and we know better in the decryption failure rate from HQC. Bike doesn't have a proof for CCA security yet, and but it has better performance. So that's tricky for us between Bike and HQC. And we really want more analysis on Bike. We really do. That would help us to make decision. Yep, next, please. On-ramp signatures. Yeah, as I explained a little bit before, that we want the additional algorithms for general purpose use, hopefully not on ladder space. If it ladders, then it got to be better than the Lithium and Falcon, basically MLDSA and FMDSA. And we have like 40 candidates right now in the round one, and we plan to we expect to make a cut sometime this year to move to the next round. And we welcome more reviews and more feedbacks from all of you. Just looking at the website, the candidates, and let us know what you think, and that would be helpful, because we would like good candidates to be standardized at the end, so that it would help improve security landscape for all of us here.
So of the 40, you said you're going to make a cut to about how many? Do you have a feeling?
My feeling is going to be around 10 or 16,
Okay.
something
So
like that.
a large cut, not
A large cut. Yeah, no, we're not doing small cut. We do
Okay,
large cut.
Thank you.
We do large cut because we want people to focus on the promising ones.
Yeah.
Because the crypto analysis is very time consuming and very costly. Yeah. And again, we're not having the on-ramp for camps right now. Not right now. So we have been received a lot of questions regarding to that. They ask, why you do the on-ramp on signatures but not on camps? Because we have the four round camps going on. And these are important too. So in SB 800-208, we specify MLS and SNFS for post-quantum security. However, in that standard, we did not allow people to do the state copy to move the secret value outside of the module, basically the SSM for backup. And that we have been received a lot of complaint about it. Mm-hmm. And so we are going to update this SP, and we plan to relax that restriction a little bit and give more guidance on how to do state management, and with the goal that to minimize the risk, but still allow people to use the scheme in the standard. And also after the FIPS 203, we will have a special publication to discuss about how to deploy ML camps in different scenarios, and what are the properties or things that people might be aware regarding to camps general or ML camps in specifically. And so that might have that will have some useful information to some people as well. And also we're working on selecting and smaller signature parameter sets for SLH DSA, basically small strings. And I expect they come in sometime in the fall, a draft selection, or at least a proposal for the community to discuss and to decide what parameter sets for NIST to consider to standardize, because we don't want to standardize too many options, and we don't know which parameter sets are the ones to go with, because different people have different needs and different opinions, and that's very, very complicated. But too many parameter sets would not be helpful either. Yep. Oh, and about the KDF, that we have a lot of questions regarding to what KDF is NIST compliance. So currently, right now, in 56C, we allow the concatenation method. So basically, the secret inputs are called Z prime. If the Z concatenate with T and Z is coming from a classical share secrets like the EC Diffie-Hellman share secret, and T can be anything, then you'll be compliant with 56C. And when the FIPS 203 is published, then if then you can substitute the set secrets in the 56C by the output from the CAM, and then it would be fine. Also, another thing people a lot of people are not aware of is that the KDFs we have with SB 800 108 are used to derive keys from Boston random key, or multiple Boston random keys. So if you can take the MLCAM key as the key derivation key for one of the KDFs in 108, and then you can derive more keys. Yeah, and you also can SB 800 108 allowed multiple pseudo random keys to be treated as key derivation key, and you can use one of the function in SB 800 108 to derive keys from those concatenation of the pseudo random keys. So these are very useful information to a lot of people because we receive a lot of questions on these matters. But if you have any other questions or any other concerns, just let us know or let me know.
So we're running out of time, but I wanted to point out something. These are already allowed, or you will be revising the SPs to allow them?
The first one already allowed. The second one already allowed.
Yep.
The third, the fourth, the last one already allowed.
Okay.
The third one.
Yeah.
The third one will
56C.
will be allowed when the fifth is published.
Okay.
Because right now we officially don't have MLCAM yet.
Yep. Okay. And then last slide, and then we need to sort of zip on. But
yeah, again, thank you the whole community. And it has been awesome several years. And without the crypto community and all the IETF and different research organizations, we would not been able to accomplish what we have done. And thank you, all of you.
Great.
Thank you.
So we have 2 people in the queue. I'm going to lock the queue just because we still have 2 more presentations, but go for it.
I'm sorry, it took more than 30 minutes.
You did, but that's okay.
Oh, I'm sorry.
That's good.
Very quick question. Update to 200 to 800 208. Do you have a expected time frame?
Oh, time frame. It's really hard this one because I'm working with other people on this.
Mm-hmm.
Yeah, if I work alone, I might have a better assessment.
Okay.
Yeah, thanks, Quinn, for your work. Just a quick question about so object ID. So I know when you publish the FIPS 203 and 4 and 5 documents, they won't have object IDs from what I heard you said, but you said they're going to be in a separate document or something. Just wondering, is that going to come out the same day that the final standard, or is there going to be like, you know, a month, or like, I'm just wondering if you have any idea of the timing of that.
Yeah, awesome. Good question. I expect David Cooper is going to send out an email discussion regarding to OIDs. Because basically there are 2 approaches that we all know here. So we have the pre-hash and the poor signatures. And how do you want the OID is a public key, right? And if you want the same public key to be signed for both pre-hash or non-pre-hash signatures or not. Based on that, you can have different kind of OID structure you want. So that basically that would be a discussion, and based on that, we will make a determination which way we should go.
So that discussion probably should start like now if you're about to eminently release?
Uh,
Because that if that discussion goes on for a while, then it might be quite a while before
No,
we actually.
I expect that discussion would be quick. I expect
Okay.
David Cooper is going to lead that discussion on our behalf, and I expect him to send a message out very soon. But I don't think anything really complicated in that discussion that would require a long time.
Okay, thank you.
And Sean, I normally cut off the line, but you beat Oids over the head with me so much.
Hi,
please.
I'm Sean Turner. I'm not going to get in the queue. I'm just not going to do it right.
Yeah, right. You're
So
good.
right now, the drafts, that, if I understand, you're saying like you could, for keys that go in certificates, you could use the pre-hash or just the regular one, right? We're not specifying the pre-hash one. The quick discussion we've had is don't do it. So just FYI, we haven't even looked at that. I just used the one pure one. So it might, you're right, it might be a very short discussion, but the general discussions that we kind of already had is just do the one. Don't do it, don't do it, don't do the pre-hash in CMS, and don't do it in certs. Smarter people than me were talking
Take
about
that one to the
Oh,
list.
yes.
We're pretty much out of time, so yeah.
But thank you, Sean.
Yeah, okay, very good. Thank you.
Okay, thank you, Bob.
Yep.
Thank you, everyone.
Yep. So Alexander,
Hi, can you hear me? Can you see me?
we can see you, we can hear you. I bet you would like to see slides. Oh, you
I
are
see.
sharing slides, even better. Why? Hang on a moment. I should be doing your slides, and why am I not seeing these? There we go. So take it away, and let's try to keep it within the 10 minutes.
All right. So I'm Alex. I will present this on behalf of the other co-authors. Our document is about a taxonomy of migration use cases towards post-quantum cryptographic algorithms. Can you please go to the next slide? So we are attempting to build this taxonomy around several criteria that we use to define which algorithms are a more fitting choice. And the criteria are the duration, so how long a deployed device or system is expected to remain in the field. The second criterion is whether backwards compatibility needs to be retained or we are free to detach from the past. And last but not least, whether the protocol that is in use has any kind of negotiation capabilities, or if it's set in stone and it just operates the way it operated when it was deployed. So what we want to accomplish is to guide engineers and other stakeholders in choosing a better fitting algorithm and parameters for a given use case. And a typical discussion: start, debate, recommend, argue, and so on. Could you go to the next slide, please? So at the previous IETF meet, we got some feedback, which we incorporated in this new iteration of the document. And some of the highlights are pointed out here. We revised the wording around hybrids. So the previous version asserted that you need them, that you must use them, but this was not a right thing to state, because there are cases when not everybody must use hybrids, and we softened the language around that, and we attempted to provide a better argument for the use of hybrids. We also acknowledged that if you choose to go this path, there are some potential downsides, such as increased complexity, for instance, or the fact that later down the line, you you will deal with a second migration where you need to get rid of this classic component, which could become compromised. And we know in practice that one migration can be very long. So if you use hybrids, now you're sort of signing up for two migrations. And this is not something you should do without giving it sufficient thought. And in the draft, we also proposed a decision tree for guiding people towards one algorithm or another. We got some comments about that, and we made substantial changes in this visualization. I guess a main change is the fact that the initial version, I would say, it has a subjective component. People asked, why am I guided towards a certain algorithm or another? And what we did in this version is we rooted it in objective, measurable things. So on the one hand, if there is a regulation that says, in this particular country or area, if you want to be able to use it, you need to comply with this regulation. So we point which document says that, and that is how you can decide. And we also rely on algorithm characteristics which are measurable, such as signature time, verification time, key size, or signature size. So these are easily quantifiable values, and there is no subjective argument about which signature is longer and which one is shorter. So this is what the revised tree is bringing to the table. In the current version of the tree, which we produced, we propose an example that is centered around the US and Germany. And our current gut feeling is that it would be very complicated to make it a globally relevant decision tree, because there would be many elements, many arrows, and it would be too dense to read. But this also remains to be seen later. In the next steps, we are considering exploring this idea that we tentatively call a pessimistic migration. And this is based on the pessimistic assumptions, that cryptographically relevant quantum computer-driven attacks will begin sooner than standardization is ready, or sooner than migration is ready. So just hypothetically, imagine this thought experiment, that tomorrow we wake up and quantum computer-driven attacks are now a thing. What are we going to do? And if you ask yourself this question, you could perhaps make some choices, take some decisions that will either buy you more time later when such computers become available, or at a minimum, that among the entire pool of targets on the planet, you will not be the lowest hanging fruit from an attacker's perspective. So with this mindset, perhaps it would be a useful exercise to consider what we can do today to make the future a little bit better. And two simple examples that we can come up with are wrapping communications into protocols that support certain post-quantum algorithms. For example, earlier, a couple of SSH versions before, they added support for post-quantum. So you could hypothetically take your TCP connection, drive it through an SSH tunnel, and you can already do this today if you have something that can work through an SSH tunnel. And another approach would be to rely on protocols that use pre-shared keys, and they encrypt traffic right away from the very first sent message, without handshakes, without any kind of negotiations. And again, this may not work in every situation, but maybe for some use cases, it might be a reasonable choice. Next slide, please. So I thank you for this opportunity to share the updates with you, and I'm looking forward to your feedback, whether you have an opinion about the decision tree or use cases you dealt with, some challenges you are handling or will be confronted with in the future. Please get in touch using the regular IETF channels and help us refine this document. Thank you. So this is as a closing remark. While you think of your comments and questions, you can also look at this.
So we actually are pretty tight on time, so I'm not seeing anyone in the queue. This is a good thing to keep discussing on the mailing list, even though we have working group last calls for other things. Any ideas, any suggestions for this draft, even though it hasn't been adopted by the working group, still quite appropriate on the mailing list. So, John, yeah, but do be quick because
I was just going to be quick. Yeah, the question about adoption. If we adopt this document, I'm one of the authors of this document, then does that give more room for the working group to actually participate? And if
not
it
really.
does,
I mean,
okay, yeah,
people
then if it-
can participate now already. So,
Yeah.
yeah.
Yeah,
The,
so I'm
work,
not
the main idea of working group adoption is then at some point there will be a working group last call and moving
Yes,
it forward.
okay.
Yeah.
Yeah,
So do,
and
yeah.
I mean, we're, like we said, we're collecting the use case feedback and, you know,
Yeah.
this pessimistic migration, possibly with all these algorithms that, you know, that are coming in the
Right.
future, right? Having kind of a companion doc to the engineers document, like, you know, the engineers, you know, you read, okay, you learn about this stuff. This is supposed to be concrete use cases. How do I actually make use of this case, right? So that's the point of this.
So, yeah, please do take a look at it, but I think we want to get through our current docs before we are adopting new. So very good. Thank you. And Tom, let me undo you and you. We can see and hear you, yes. So, but you would probably like your slides up.
I mean, that probably makes it easier for everyone. Okay, you'll run the slides then.
I can run the slides, and we are 9 minutes away from the end. So do, and I know you said you could do it under 10 minutes, but you have 17 slides, so do be aware.
So most of that is actually last time's presentation. That's just there for people's convenience to refer to later. So don't worry, it's just 4. So yeah, I'm talking about hash-based signature schemes, and specifically, again, talking about how to deal with the stateful part of hash-based signature schemes, so the XMSSs and the LMSs of the world. And we, together with a bunch of other people, wrote up a little document about this. So if we go to the next slide. So this is the slide that's a repeat even still from the last time. Basically, we have this divine commandment of thou must not use a signing key more than once without updating the state. So you can do that using SHDSA, but people also want to be using XMSS and LMS. How do we reliably deploy these schemes? How do we run backups and disaster recovery? And what do you need to think about? There's a lot of foot guns here. Basically, this document tries to help people not shoot themselves in the foot. So if we go to the next slide, we had some discussion on the mailing list, and it seemed that people agreed that this is worth documenting, at least collecting some ideas. It's never probably going to be complete, but it seems worthwhile, at least to us. Some people suggested that we added, for example, when are stateful schemes appropriate in the first place? So that's an interesting, I think, couple of paragraphs that we could add to the document. So that's in the linked issue is a place to discuss that if you want, or of course just in the mailing list. And of course, we can always see if it's appropriate to add more things to this document. But yeah, the next slide just says, please adopt. As far as we're concerned, the document is in a good place to work on collaboratively. I mean, we can do that, as Paul said, also without it being adopted, but also it seems good to start moving towards the next steps in the process. So yeah, that's where we're at.
So the rest of the slides are backup slides?
All of the rest of the slides are just literally last time's presentation. Okay. So if anyone missed that one, then they can just go to this meeting's materials and just find that immediately.
So since we do still have a few minutes, I didn't mean to rush you. I thought you did have 17 slides.
This was literally all I had.
Yeah, I see, right. Who here, and this, we'll do this on the list, who here is interested enough, like, I know some people are only interested in chems anyways, but who here is interested in stateful hash-based systems? So that's not a large number. I would say for now, we probably don't want to adopt yet. And I'm not saying that means we won't adopt, but I would say let's try to work through some of the other signature stuff that there's more on. And again, you absolutely can use the mailing list to improve and to flesh out. I'm not really happy with the idea of using the mailing list to encourage interest in a new signature scheme. However, we know that there are some people interested, and we know that it's a use case in some areas. And speaking as somebody who has to deal with DNSSEC, that's a place where maybe some of this is interesting stuff. So it's not like, oh, this is a weirdo off the side scheme. It's something that's well known. But I would say maybe we don't push for adoption yet until we've hit more of the current work and then do that. Are you scowling at me, or? Oh, just because some people have suggested stateful hash base for DNSSEC. No. I hear you. I hear you. But, and again, this working group is meant to be helping the whole IETF. We're not like doing it for one scheme. So there may be other areas where they care about signatures. The stateful hash-based ones, even though large, would really solve a thing. Then we should adopt this. If it turns out there's really not much interest at all, we might leave it alone. But I believe there will probably be interest over time.
If you
Yep.
If you let me quickly, we're not proposing new schemes, right? XMSS
Right.
and LMS are
Right.
already IETF standards.
Yeah, yes,
We're
exactly.
trying to help people run them, run systems in which those schemes are integrated.
Right. So here's the basic overview on it. We can, again, this can be discussed on the list. That's fine. We'll probably delay working group adoption until we've at least gotten through the hybrid stuff that we are working on now. I have a hard time picturing a hybrid with a stateful. Yeah, but that could be weird. So anyways, yes. John?
Yeah, sorry, my computer died. This isn't a comment about this. I know everyone wants to leave, but I just wanted to give a quick update about the positive work we did at the PQC hackathon, because it's related to this whole group.
We've got
it's like
3
we
minutes.
got like 1 minute or whatever.
Yeah.
So at this hackathon, I think I presented on this in November. So this time we actually got a lot of Git actions working, so people can submit their artifacts. So if you want to test interoperability in any of these new algorithms, like what Quinn was talking about, we support them in our project, and now you can upload your artifact zip, and GitHub action will automatically run it against libopen quantum safe, but we're actually going to add bouncy castle as well, and even the NIST ACPB vector test, or ACPP. We had one of our members download those. So I did it today. I updated my artifacts. I uploaded it within 5 minutes. I had it in the compatibility matrix. It showed, what I was compatible with and what I wasn't. So it's a lot of automation we did, and it's really positive. So if people want to join or test, their implementations of these PQ algorithms, obviously we're going to be adding like the round 4 ones, and we're going to continue. So it'll be a really good way to interop with all this new PQC stuff. So a lot of positive stuff there. So let me know
John,
if
2
you're interested.
questions.
Sure.
One is, are you also planning on doing more work at the hackathon at the next IETF?
Oh yeah,
Okay,
the next
fine.
hackathon.
So this is a running.
Yeah, sorry, it's a running thing, and we actually do have monthly meetings every Tuesday at 8 a.m. EST. Our team gets together and meets. So if people
That was my
join,
second question. Can you send not only what we did the last time, but how to participate between now and 121 to the mailing list? And since your meetings are only monthly, it's fine to actually update the list every month with what has happened.
Yeah, sure. And
Okay.
we've also had interim hackathons. We might do one in September as well.
Right.
Just we take a day. So, yeah, so I'll send that.
I'm just saying
information
we're
on the
not
list.
hearing much from you, and I see you making a lot of progress. So I think it would be great for you to keep the mailing list up to date.
Okay.
Okay.
Yeah, I will do that.
Thanks.
Thanks.
Good. We're a minute short of being done. Thank you. Please do follow the mailing list a little bit carefully because we are about to start doing working group last calls and such like that. For those of you in the room who have never posted on the mailing list, a working group last call is a wonderful time to say, I read it and I had absolutely nothing to say. That's a perfectly valid thing to say, but an even more valid thing to say is, I read it and I have this minor thing to say, or I read it and there really could be a paragraph or a section here to help me get from this one to that one. All of those are great things, especially for a working group like this where we're not producing protocols. So do please watch the list and strongly consider contributing as we get close to the end on things. Thank you very much.